Aloha! Thanks for joining me for a little lesson on the general senses. My name is Trisha Hornback, and today we will take a closer look at the general senses of pain, temperature, touch, pressure, vibration, and proprioception. So this is Bob. Bob gets stimuli pounding into him all the time from every direction. He has to interact with things like pain, temperature, touch, pressure. So this the general senses, as well as the special ones, the ones from your cranium, smell, taste, sight, hearing, and balance, they all work together to let us enjoy our sense of sensation. Sensation, that's the actual awareness of the stimuli. Hey, this is an airplane. I wonder what it does. And then we have perception, or the act of perceiving the stimuli. Look, this was a paper airplane, but if I throw it, it can fly. When it comes to science, everything is easily understood when it's classified, and there are but 3 ways to classify sensation from the general senses. The first is by their body location. The second, the type of stimulus they detect, and the third, the structural complexity. So let's start talking about the location of these receptors. There are 3 general sense receptors. They are exteroceptors, proprioceptors, and interoceptors. Exteroceptors are going to tell us what sort of stimuli is interacting with us from the outside in. Things that are going to interact with our touch, pressure, maybe our general or our special senses of sight, that kind of thing. Those are all exteroceptors. We get this information from free nerve endings, Ruffini's endings, which kind of help us with the stretch, and then proscenium corpuscles, which also help with pressure, stretch, and vibration. Proprioceptors on our muscle spindles innervate our skeletal muscle, telling us where we are in relation to ourselves. There are also proprioceptors on free nerve endings and Ruffini's endings. Finally, interoceptors are those guys that help us innervate the visceral organs, and they do this through free nerve endings and proscenium corpuscles. The second way we classify is to look at the type of stimulus that is detected. The 5 kinds of receptors that detect stimulus are mechanoreceptors, thermoreceptors, photoreceptors, chemoreceptors, and nociceptors. I thought these might be hard to remember, so I made a mnemonic. Many tall people cry naked. MTPCN. Mechanoreceptor, thermoreceptor, photoreceptor, chemoreceptor, nociceptor. Many tall people cry naked. Well, since I didn't want to get in trouble for showing a naked man on my presentation, I have opted for this guy. He is indeed crying naked. I think he's upset because many tall people cry naked too. Okay, so here is a run-through of the receptors and what sense they detect. Remember, the general senses are pain, touch, temperature, pressure, vibration, and proprioception. Mechanoreceptors are everywhere. They are found in free nerve endings, the root hair plexus, Merkel discs, Messner's corpuscles, Pacinian corpuscles, and Ruffinian's endings. Pretty cool. These mechanoreceptors help in the areas of touch, pressure, and vibration, the exteroceptors, in the blood vessels and digestive reproductive tracts, the interoceptors, and through proprioception while in the joints, obviously the proprioceptors. The most sensitive mechanoreceptors in humans are found in hair cells in the ears. The cochlea's follicular receptors transduce the sound for the brain, and these hairs also contribute to equilibrium. Next are the thermoreceptors. These guys are sensitive to temperature change. The free nerve endings in your body detect these temperature changes. The free nerve endings are in most body tissues, so the body's internal and external temperature can stay in homeostasis. Thermoreceptors are found in your dermis, your skeletal muscles, your liver, and your hypothalamus. Next, we have the chemoreceptors. These guys sense liquid or lipid-soluble stimuli. They respond to stimuli that it's tasted, smelled, or maybe any changes in the blood, that kind of thing. These guys like to get messed up. Now for the nociceptors. These guys detect pain. Painful stimuli often let us know that there might be harm in the stimulus. Our body tends to not care for pain very much, so having these guys around works. They're found in skin, joints, bones, and blood vessels. But sadly, nociceptors don't adapt well, so an injury can go on hurting for quite some time. Some resources don't classify photoreceptors in this category, but since your book does, I'll add them. Photoreceptors are receptors that respond to light energy. They are found in the retina of your eye. Keep in mind that none of these receptors types work solely. They do work in concert with others to produce a constant reception for our bodies to run smoothly and homeostatically. For example, if I held an ice cube to your finger and asked you what receptors might be, inactivated, you might first say thermoreceptor because of the cold, but if you continue to hold the ice cube there for quite some time, you might activate some nociceptors because it's too cold, it hurts. You'd also recognize the pressure of the ice cube through mechanoreceptors. Okay, now on to my lovely hair model that I have very handsomely drawn for you. I want to show you where these receptors show up on your body. So I thought it might be easy to see on a hair model, the one that I'm about to draw for you. What I first want you to see on this very, very basic skin model that I've drawn for you is the nerve endings that are near the surface of the skin. But while these free nerve endings might be near the surface of the skin, they actually are on just about everything. They serve as interoceptors, proprioceptors, and exteroceptors. They also work as chemoreceptors, sensing differences in body chemistry from maybe a pollutant or from a bowel irritation. They also serve as thermoreceptors to make sure our body is in temperature homeostasis. Free nerve endings activate mechanoreceptors that respond to maybe the sense of someone's touch. Finally, those guys also serve as nociceptors, detecting pain stimulus. The next structure is the Merkel discs. These are modified free nerve endings, as you can see in my wonderfully handsome drawing. Merkel discs are only on the surface of the skin. These serve as both mechanoreceptors, and since they are only on the surface of the skin, they are exteroceptors. Then we have the hair follicle receptors, which would make sense since they are hair follicles to be on the outside, that they are also mechanoreceptors and exteroceptors. Okay, on to Messner's corpuscles. That's the red guy, circle, oval there, filled with red little squigglies in his head. They're usually found in hairless skin, so ignore the fact that there's hair on top of that model there, such as in the soles of your feet, hairless, palms. Moving on to the Pacinian corpuscles, they are the blue guys that you see here. Kind of look like an inside of an onion when you put some paint on it and then turn it over and you print it. Looks kind of like an onion. Next, the little green guy here is Ruffini's ending, and by looking closely at it, well, not my drawing really, but you can see a bunch of receptor endings that kind of form all along this capsule. They kind of encapsulate it, and they work a lot with stretch, and that's important, and also in pressure. Ruffini's endings are also pretty good first responders in the mechanoreceptor area because they work well with the stretch and the pressure. Then there's these muscle spindles that are found particularly in extremities on the skeletal muscle. So imagine someone doing yoga. These muscle spindles are responding to stretch by detecting tension and the length of the muscle. They work wonderfully for proprioception as well. Golgi tendon organs allow us to detect tendon stretch and tension. If activated, they will allow the muscle to relax. Once again, they are mechanoreceptors. They detect stretch, and they're very good for proprioception. And then there are joint kinesthetic receptors that are found in our synovial joints. They really help with proprioception by letting the brain know where you are and where your joint position is relative to maybe where you want to go. So there they are, the general senses. The mechanoreceptors, the thermoreceptors, the photoreceptors, the chemoreceptors, and the nociceptors all work together to help us understand all of our general senses. There will be a short quiz following this presentation that you will not be able to participate in because